Alright guys, we're going to go over a couple things that we covered yesterday and go over a couple new things today just to make sure that we understand different ways of actually graphing it. Okay, so yesterday we learned how to graph these things on a calculator and how to use the calculator to solve everything. Today we're going to be starting to work on these things by hand. Okay, so get your worksheets out. Let's turn to the front and let's start working. Alright, quadratic functions. We talked about these. What makes something quadratic? And we said anything that has a degree of 2. What that means is that the biggest exponent is 2. Biggest exponent is 2. Alright, and a quadratic function will look like this. Y equals ax squared plus bx plus c. This is called standard form. So let's make sure we list that again. Standard form. So when we look at this, that first part right here, this ax squared, because that one's being squared, that's the quadratic term. That's what makes this whole thing quadratic. So it has a quadratic term. Okay, now these other terms, they help kind of figure out where the vertex is located and everything else. So this b of x, that middle term, because that has the biggest exponent on this x is a 1, this is called the linear term. And that last one, that's c, there's no x on it, so we're going to call that the constant. It's a constant because it doesn't have a variable, so it doesn't change, it doesn't vary. Alright, so that's just a quick review of what we kind of did yesterday. Okay, now it says use your graphing calculator to graph the quadratic equation. So what I want you guys to do right away, okay, I'm going to give you about 30 seconds, 40 seconds to go ahead and graph this on your calculator, just so we can kind of see what's actually happening. So go ahead, take your calculators out, graph it, and let's just take a look at it. Now go ahead, take the calculator out, go ahead and graph it. You done yet? Come on, that was like 20 seconds already. Alright, we got it up, all graphed on the calculator. Okay, now that you actually have that thing on the calculator, we're actually going to be creating that image by hand today. Okay, so let's go ahead and get started. Okay, so this U-shape, that we have, that's called a what? That's called a parabola. Okay, and the first thing that we're actually going to find in this parabola is the vertex. Okay, now a vertex, let's scroll down here, if this parabola opens up, that vertex would be right at the bottom. Since it's at the bottom, it's the lowest point of the graph, we're going to call this a minimum. Okay, if the parabola opens upside down, that vertex would be at the very top. Because that's the top, that's the highest point of the graph, we're going to call that a maximum. Okay, so the definition of a vertex is the max or minimum of a quadratic function. And there's an actual formula that goes along with this. And this formula, make sure you guys have this in your notes, is x equals the opposite of b over 2a. Okay, now how in the world do we actually use this right here? We call out a standard form for a quadratic function is y equals ax squared plus bx plus c. Okay? Now, the equation that they gave us, I'm going to write it right underneath, is y equals x squared minus 4x plus 1. So the a value is right next to the x squared value. Alright, so if you notice, I actually don't have an a value here. So if there's no number next to this x squared, the a value is a 1. The b value is right next to x, and the c value is by itself. So in this case, my a value is going to be 1. My b value is going to be negative 4. And my c value is going to be 1. Alright, so when I throw that in to this vertex formula, I get x equals, I have a negative sign, and then my b value is negative 4. So when you do that, you can do click or whatever you guys do, that becomes a positive 4. Okay? The denominator has a 2, and the a value is 1. So 2 times 1 is 2, 4 divided by 2 is 2. Okay, so I know the x value of my vertex. The problem is, the vertex is an ordered pair. It's a point. Let me move that out of the way. So you only found the x value. Let me put the x by it. You need to actually find the y value. Okay, so what we're going to do is we're going to take that equation. We're going to take this value 2, and we're going to plug it into my x values to find my y. So I have x squared becomes 2 squared minus 4x becomes minus 4 times 2 plus 1. 2 squared is 4. Negative 4 times 2 is negative 8 plus 1. And when I combine all these, I get negative 3. That's my y value. So in this situation, I have an ordered pair up to negative 3. When you guys look at the calculator, make sure that you have the same vertex. It should be at 2, negative 3. Okay, so 1, 2, 1, 2, 3. 2, negative 3 is right there. Alright, and I'm going to put a little V for vertex for that thing, just so I know I have it. Okay, and when we create a table, we're going to actually use this table, I'm going to put that 2 and the negative 3 right next to it. Okay, it says this special point is called, we're going to call that the vertex. Alright, so, to help get other points on the graph, let's pick easy ones that are surrounded by the vertex. So if this is 2, we're going to count up. We're going to go, this will be 3 and this will be 4. And then the other side will count back down. If this is 2, then we're going to go 1 and 0. Alright, so all of these numbers, 0, 1, 2, 3, and 4, they're all going to go into the x value so you can get your y value. Okay, now, if you plug in 0, that's the easiest one. If you plug in 0, right here, 0 squared is 0, minus 4 times 0 is 0. These are all going to cancel, and you're just going to get 1. So I'm going to actually show you the work just for number 1. If you plug in 1 here, this would be 1 squared, minus 4 times 1 plus 1. Well, 1 squared is 1. This becomes minus 4 plus 1, and I'm going to get negative 2. Alright, I'm going to give you like a minute or 2 minutes. Let's plug in 3 and substitute in 4. Let's find out what values you get there. Okay, what did you guys get for 3? When you plugged in 3, you should have gotten negative 2. If you didn't, make sure you guys are paying closer attention to the squares and everything else. When you plugged in 4, when you substituted that in, you should have gotten 1. Alright? If you notice, you still have symmetry in this table. So when you plugged in 1, you got -2, and when you plugged in 3, you got -2. The other symmetry is when you plugged in 0, you get 1. When you plugged in 4, you get 1. These should work out symmetrical. So now that you have this, the only thing that's left to do is actually plot the graph. 0, 1. That would be the ordered pair. 0, 1. 1, -2. 1, -2. 2, 3, that's the vertex. We already put that in there. Then we have 3, -2. So 1, 2, 3, down 2 is that point. And then 4, 1 is right here. Over 4, up 1. You guys can start to see your parabola. So when you draw it in, make sure it looks like a U. And that should be exactly what your graph looks like on the calculator. Okay, so we're going to call this graphing with a table because you're actually using this table to help you guys create the graph. Alright? Alright. What else do we need to talk about? Alright, the axis of symmetry. We didn't do that yet, so let's talk about the axis of symmetry. So let's go back up. The axis of symmetry is the line that cuts the parabola right in half. So, if I were to cut this parabola right in half, and you can see me drawing this line over here, it goes right through the vertex. That line is called the axis of symmetry. The axis of symmetry. Okay, so when we come down here, let's put that in the definition. Axis of symmetry is a vertical line that bisects the parabola, and we're going to write through the vertex. Uh-oh, having computer problems. Let me fix it. Okay, through the vertex. Okay, so there's my line, goes right through the vertex. Now we are actually going to create an equation for this. So how do you create the equation of a vertical line? What does a vertical line look like as an equation? You're right, looks like x equals. And where does it hit the x-axis here? Hits the x-axis right at 2. So this axis of symmetry, the equation for it is x equals 2. Alright, the y-intercept, we talked about this yesterday. The y-intercept is when you plug in 0 for x. And this is actually one of the first things that we find, right? If you look at our function, let's go back up to our function. I'm going to erase something so I can make it look a little neater up here. If you look at our function, if you put in 0 for x, that would be gone, and that would be gone, so that would be your y-intercept. That's the c term. So your y-intercept is always that last number. So what we do is we're going to say this would be the ordered pair 0 and c, meaning that's this c term over here. It's always going to be that last term. Alright, last but not least, the symmetrical point. The symmetrical point is going to be across from the y-intercept. So let's go over to our graph so we can actually show you what we're talking about. The y-intercept is where it crosses the y-axis. So in this case, this point right here, I'll use red. This point right here, that's my y-intercept. Now, how far from the middle of my parabola is it? How far from this axis of symmetry? It's 2 spots. So the symmetrical point would be 2 more spots over, 1, 2. So this point right here, that's going to be the symmetrical point. Okay, I know that took a long time to get to the first one. That was about 15 minutes. So I'm going to do one more, and we're going to go through it a little bit quicker. Alright, turn your papers over. Alright, important parts of the parabola. Alright, so let's go to the bottom right here. This bottom part right here, what's that called? You got it. It's called the vertex. And the formula for it is x equals the opposite of b over 2a. Alright, this point over here, this one is called the y-intercept. Okay, how do you find the y-intercept? You put in 0 for x. And we said that's going to be the point 0 and c. Okay. This next one, let's go up here. It points to this line. What's that line called? It's called the axis of symmetry. Okay. Formula for that is x equals the number. So that number will change depending on what the vertex is. So we got to make sure we write right through the vertex. And that last point, this last point over here, see how it's across from the y-intercept? That's called the symmetrical point. And that symmetrical point is going to change all the time. Okay, so we'll go through one more, we'll go a little bit quicker. So, number 1 says find the y-intercept, the equation of the axis of symmetry, and the x-coordinate of the vertex. Make a table of values and use the information to sketch the graph. Determine the domain and range. Okay, there's a lot going in there. So, let's break it down to things that we can manage, okay? The first thing I want you to find, real easy, is the y-intercept. Okay, the y-intercept is when you plug in 0 for x, so that would cancel, that would cancel. You know the y-intercept right now is at the point 0, 2. It's this value right there. Okay, so if you want, you could put that point on your graph. 0, 2. There we go. Alright. From there, that was the first step. The second step, we are going to find our vertex. And who remembers the formula for vertex? If you don't, look up at the page, and it is x equals the opposite of b over 2a. Alright, so again, what's my b value? You got it, my b value is -4. So, I have the opposite of b. That negative, it's like saying the opposite. So the opposite of b is going to be +4 over 2 times my a value. The a value is next to the x squared, that's 1. So when you do this, you get x equals 2. We're going to take that 2 and substitute it in right into the middle. Oops, why did I put 4? Let's get rid of that. We're going to put that right into the middle of our table. Okay, so to help finish this table off, let's rewrite it. If this is 2, then we're going to go 3 and 4. We're going to go 1 and 0. Alright, these are the numbers 0, 1, 2, 3, 4 that we are going to put in for x's. So if you put in 0 for x, oh, we already did that one, we got 2. If you put in 1 for x, that would be, and I'll write it again, that would be 1 squared minus 4 times 1 plus 2. Do all the work right there, and you would get -1. Okay, again, I'm going to give you a couple minutes. Go ahead and finish this table out. Okay, when you plug in 2, you should get -2. When you plug in 3, you should get -1. we substitute in 4, you should get 2. Okay. Good. So, let's go through these. Plot the points. I already put the point 0, 2 on there. That's good. I have 1, negative 1. So, right 1, down 1 is that point. I have 2, negative 2. So, right 2 and down 2. I have 3, negative 1. So, over 3, down 1. And I have 4, 2. So, right 4, up 2. Do you see your parabola? Hope so. Draw it as close as a U as you can. And let's go see if we hit everything in the directions. Did we find the y-intercept? Yeah, we did. We got that listed. The next thing is the equation for the axis of symmetry. Okay, so we have to draw in our axis of symmetry. It goes right through the vertex. Okay, so number 3, the axis. It's a vertical line, so we write that x equals, and it hits the x-axis at 2. So our axis of symmetry is x equals 2. Alright, and it says last but not least the x-coordinate of the vertex. Well, we actually found the entire vertex. It was at 2, negative 2. So we actually did that as well. So that's everything that they asked you guys to do in this case. Alright, so your goal is to try number 2 for homework. But before we do that, let's talk about domain and range. Domain are all of your x values, and range are all of your y values. We've done this before. You guys actually did this probably about a month ago. So domain, how far to the left and right does this thing go? If you notice, there's no stopping point. You can't tell where this thing is going to stop going to the left. And as you trace it to the right, you can't tell me where it's going to stop on the right either. There's no actual stopping point. So this domain is going to be x such that x equals all real numbers. All real numbers. The range. Range are the y values. That goes up and down. If you notice, this graph points up forever. So these lines are going to keep going up and up and up. So it doesn't stop going up forever. But there is a minimum. There is that lowest spot. Okay, what is that lowest spot? The lowest y value is negative 2. So how do we write that it's going to start at negative 2 and then go up forever? We're going to write it y such that y is greater than or equal to negative 2. So your hint when you're working with the range is to look at the vertex. Look at vertex. Okay. Let's go to 3. And almost done. After this, I'm going to let you guys try the others, and that's going to be your homework. Is going to be to finish this worksheet. Alright, 3 to 4. Determine whether the function has a maximum or a minimum value. So these are key words that say look at the vertex. And then it says state the maximum or minimum value of the function. Alright, so we talked about this before. If the graph opens up, it's going to have a minimum. And if the graph opens down, it's going to have a max. So just by looking at this equation, we have to find if the graph opens up or down. Now you could graph it. We showed you guys how to do that yesterday with the calculator. But just by looking at it, what do you think? I hope you're saying that it opens down, and it does open down. Why? Answer is because what's x squared? What do you have in front of there? We have a negative. That negative means this thing opens down. So if it opens down, which one do you have, a maximum or minimum value? You got it. You got a maximum. Okay? And then it says, then state the maximum minimum value. Well, that means you actually have to find this point. Okay? And how do you find it? You find the vertex. They're asking for the vertex. And we already showed you guys how to find that. Okay? So, I'm not going to help you. I'm not going to finish this problem for you, but in order to finish this problem, you got to find that vertex. Okay. You got about, what is it? Probably about 15 to 20 minutes left. Finish this worksheet for homework. We'll go over it on Monday, and good luck with it. If you guys have trouble, I will be in school today after school. So if you need a little bit extra help, you can come tonight after school. You can come tomorrow morning. I'll be there. All right, good luck. We'll see you guys.